All right, so how did Java go? Not too bad converting Python over to Java once you got into it and got past the curly braces and instead of indentation stuff. All right, so that was kind of the point. So let me open up our dungeon crawler thing here. Hide this. All right, so just as a reminder, we're starting to work on our well, I'm going to finish introducing it, but it's called a dungeon crawler. Um, it's going to be text-based for the rest of this semester, and then we'll upgrade it to visual interface and using Unity, unless I get convinced of using an alternative um, tool for the Spring for coding too. But we can burn that bridge when we get to it. So the idea is that this is going to use a set of dice behind the scenes, like, okay, I want to attack this monster. So you roll some dice, decide, okay, did I roll high enough to attack this monster? We're going to talk about that. The monster might have something called like an armor class. And if its armor class is 10 and you roll a 10 or better, that means you're going to hit the monster. So now you roll how much damage you're going to do to the monster, that kind of stuff. But that'll be more the gamification side of things. Early on, what we want to do is build a series of interconnected rooms that our player can move through. That we effectively have a little prompt that says the obvious exits are to the north and to the south, for example. What do you want to do? And we type in north. So your guy will leave the current room and go to the room to the north. Room of the north might say we have one obvious exit. There'll definitely one back to the south because that's where we just came from. And then maybe there's one to the west. So if we try to say, well, I want to go east, it's going to tell us there isn't a room there, try again. So we're going to be processing a prompt where it's waiting for users to give input, and then we're going to be responding to that input. So we're going to start off by just building a couple of rooms. We'll build an object for our rooms and decide what do rooms have in them. And then what we want to do is we want to transition to, well, let's say that I want to be able to build dungeons that look different. Rather than having to go in and hard code 15 rooms, maybe I can have a document in a specific format, maybe it's JSON, that describes my map, that our program can read that in and generate that map. So we could have multiple maps with the same program. This is kind of the pathway we're going. Okay. All right. So if we open up Keynote here. Oh, here's a sneak peek of my thing for the Wednesday pitch. Everybody has that on their calendar, this guy. Yep.
So it's basically where like we as people can like pitch ideas about what we want.
Well, you wouldn't be able to pitch them in this event because we've already had everybody for this one, but we're going to have these events, I think maybe like every other month. So if you did have an idea or wanted to get involved in a project, you could certainly talk to me or talk to one of the other folks in the lab and we can kind of figure that out. I mean, the idea is that even freshmen can get involved in these things. That you learn from it as you get involved. But yeah, so I'll be talking about our swarm project. Well, what I can say that's our Department of Defense grant that we're working on, but it's pretty cool, like world-changing stuff. So let's see. So I was opening up this and getting to the notes. All right, so let's design something here. So let's say we want to have just a couple of rooms. So we'll have this room and we'll have this room. And we want to be able to move back and forth between two rooms, just to keep this as simple as possible. All right, maybe this room is called R1. Maybe this room is called R2. All right. So when we start thinking about what kinds of things should go into rooms, well, a room, so our classroom, classroom, all right, that guy should have probably a name. Maybe one's called R1, the other one's called R2. If we were doing this in a traditional, what's called a MUD, multi-user dungeon, there would probably be a description. But for us in here, our description would probably be the same thing as the name. The description would kind of be like, you just entered the dungeon entrance and it's damp, blah, 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 storytelling crap. Okay, so we're not going to do that in ours. We're just going to have a name. Okay, so we're standing in this room. Now, our room is going to be able to have things in it like a person initially. We want to be able to walk around our dungeon. So a room is also going to keep track of a player. Okay. That means we also need to know about players. So maybe this is our player guy. So we'll call that P1. And P1 might be in this room here. And when he goes to the north, he's going to leave this room and enter this room. So a player, let me just finish this idea real quick. So a class player is going to have a name. And should a player also know what room they're currently in? Okay, so the room knows about us, and we should also know about the room. All right, go ahead.
I like to a little bit, but if we were to create the classroom, right, and then we would have like inside of the parameter, name and player, but we only wanted to describe the name of the room rather than putting the player, could I just put Nolan for player?
I need way, way, way more context to give an answer to that.
It's like.
Like, I don't think it's context you have the capability of giving this point because haven't been far enough into the game. Because realistically, you're probably not going to build rooms with players into it. Like if we have two rooms, chances are the player's just in one of those rooms. So we would probably instantiate rooms with their name, and then the player would be null by default. Every room starts off as an empty room with nothing in it.
Necessarily have to put that second parameter. That's my big point. It's just like, do I need to include it?
Okay, so if you have a constructor that potentially could take two parameters, and you could build a room with a name as well as a player if you want to. So like an optional parameter. Some languages allow for optional parameters. I would say it's probably not great programming practice. What you would probably do instead, if you really had a need for that, is you'd write two separate constructors. One that just took a name and the other one that took a name and a player. Maybe you use that constructor when you're building the dungeon entrance or something. But I think it's probably going to be since we already know that players are going to have to be able to leave rooms and players are going to have to be able to enter rooms, it maybe makes sense to build our rooms where a room just has a name. It's sitting here. It's got nothing. And it knows about the player that's in that room, but only when the player gets into that room. So we would have the abilities to add a player to the room at a later date after it was born. All right. So let's start off with it as simple as possible. We're just going to think about rooms here for a second, because we're probably also going to have a room is going to have a link to potentially other rooms, right? Up to 4. Let's just keep the cardinal directions, north, south, east, west. So potentially a room could have doors leading to 4 other rooms. Make some sense? But let's keep it as simple as possible first. So we're going to go back here to our code. And I'm going to create a new file. And we're going to call this guy room.java, capital R. That's going to be the name of our class. So our constructor must be called the identical thing. And the class name is the identical thing. So we're going to have classroom. Is that big enough? Everybody can see that? All right. So, and then our constructor must be named the same thing as the class itself in Java. Whereas in Python, your constructor is always named underscore underscore init underscore underscore. All right. And we decided that at least initially, when we build a room, it's going to just have a name. And what we ultimately want to do is we want to set this room's field for name equal to whatever name was passed into the constructor. Python doesn't require us to predefine our fields. A strongly typed language like Java does. We have to give types for our variables. So we would go up here and we would say, okay, we are going to have a string called name. All right. Now, just to keep things as clean as possible for right now, I'm going to omit putting public, private, protected stuff in here. I would almost always make this private. But let's just keep it as close to Python as possible for a moment. And now, just remind me, we talked about it for a few minutes, but why might I want to take a field like name and make it private versus this is package level? Go ahead.
You wouldn't want methods to be able to, we don't want it to be for that specific method, which is.
Okay, yeah, so I mean, if we wanted to police it, we're going to say, hey, a room has this internal knowledge that it has a name. And we don't want some external entity to even have the capability of modifying that room's name. If we wanted to police that programmatically, we could make this guy private. And then if we tried to set that name externally to this class, it would yell at us. It would say, yeah, this guy's a private member of the room class, so you can only access it from within the room class itself. You're trying to change the name from some other part of your program. So one approach in programming languages is we can decide to put up those walls and put up those barriers, which is the approach that our C-based languages take. So C++, Java, C#, Swift, they all take that approach. Or the Python approach would say, look, if you don't want to have something change from the outside, just don't change it. Programmer, don't misuse the tool, right? So do you want to have a chainsaw that has biometrics and everything around the saw to protect you, and that you have to unlock it 5 different ways before you go to use the chainsaw? Or do you just use common sense and maybe don't put your hand on a running chainsaw? Both can be fun in their own right, I suppose. All right. All right. Have you seen the commercial with the guy juggling chainsaws? And this random dude just walks up, just give me one. How do you find out that you can juggle running chainsaws? Yeah, like what was day one like? Or are you an 11th generation chainsaw juggler? All right. So we're not going to mess with public, private, protected right now. We're just going to purposely not going to change it. So we'll just keep our code looking as Python-like as possible. All right. So then in here, we're going to say this dot name is equal to name. Remember, this is how an object refers to itself from within itself, just like self is what Python uses. All right. Then we're going to go ahead and we can decide, do we want to allow a room to display itself, or do we want a room to be printable? I think in this particular case, we have these rooms, we might say room R1, display yourself. So we're telling it, we're giving it a behavior rather than overriding that toString thing we talked about last week. So we're going to have a function that's going to return nothing called display, and it's going to take nothing. This is being defined inside the room class. So if I'm an instance of room and somebody tells me to call my display function is going to display things to the screen, not return a value, which is why our return type here is void. Again, Java is a strongly typed language, which means we have to tell it what kinds of values variables are built to hold, what kinds of values a function is going to return. If the function's not returning any value, we have to say, don't expect this to return a value. Its return type is void. Java makes us do that. Python, if you're not going to return anything, don't return anything, but then also don't write code that relies on it returning something. We've seen that give us that value none in Python, right? So it's that exact same mentality. Python just says, if you don't want it to work that way, don't do it. Java says, if you don't want it to work that way, you could put up barriers so that even if they wanted to do it, it would break. Go ahead.
Getter, and it's just void display the fact that it's public and it have void or
Said the getter, or you mean the two-string thing? Okay, well, it's unrelated. So, she's mentioning these getter methods. So if we were going to make this guy private, for example, and we wanted to give somebody read-only access to this, we would have a function that returns a string. Maybe we would call it getName, just by naming convention. And this guy would return this .name.
But the difference is that one actually returns it.
Well, yeah, I mean but this getter and this method are not solving the same problem for us. Well, I mean, this guy's just displaying system .out.println room.
And void makes it so that way I don't have to return it. That's why.
Well, it makes it so you're not allowed to return anything. Yeah, but I don't want to connect these two. These are solving completely separate problems. You see that? getName, this function we wrote, we're calling it the type of animal this guy is called a getter, but we don't have to name it anything specific. We just typically will call it get whatever field name we're returning. But this guy, his job is to return a string. What string is he returning? He's returning the name field of this row. So this function returns a string. This function returns nothing. It prints something out to the screen. So they're solving different problems. One of them gives us access to a private variable internally. The other one says, whatever displaying means for a room, I want you to do that. Make some sense? You had a question?
So what, sorry, repetitive, but so what is being voided?
Well, here, well, yeah, nothing. If I try to say return LOL here, it would scream at me when I go to compile this because it would say, look, you told me you weren't returning anything. Then you went and tried to return something.
Then basically like gatekeep any return, so you can still print through.
Void, yes, it does do that. That I would call that kind of the side effect of it. When you say a function returns void, you're saying this function will not return a value. You could kind of think of it as like a Python function that boils down to none because we didn't return it. But so what the side effect would be, it acts as a gatekeeper. You're not allowed to return something. So if you have no intention of returning something, and then you're going to write 600 lines of code and you forgot that you had no intention of returning something, and you go and try to return something, when you go to compile it, it's going to scream at you. At that point in time, you can have the conversation with yourself that, oh, well, at the beginning, I didn't think I was going to return anything, but then I changed my direction as I was going through here. And in the end, I actually do want to return something. So you would just go back up and change the return type at the top. But in Java, we have to specify what we intend to do with this function. Is it going to return a value? If yes, what kind of value is it going to return here? So this guy's job, getName, is going to return a string. Therefore, I have to advertise it's going to return a string. This guy's job, display, is going to be to print some stuff to the screen. And since it's just printing stuff to the screen and I have nothing that I actually want to return, we could do both if we wanted to. If this tool that we're inventing here, we had a reason for it to display some stuff and return some stuff, we could do that. But in this case, we're just asking a room to display to the screen itself, whatever that means. and we have no intention of returning anything, we have to say, I have no intention to return anything. We cannot leave that blank. Do notice here, though, that constructors don't have a return type. If I leave that public thing off there. So a constructor looks a lot like a method, but it actually isn't a method because it does not have a return type. Why don't constructors have return types in modern, any modern object-oriented language? Talked about this last week. Why would we not put a return type in front of a constructor? Go ahead.
That what certain functions, I don't know the exact name of it, but like a certain function's values. It's not meant to like give you anything.
Okay.
It's just meant to set.
So the job of a constructor is to like initialize this object as it's being born. That's true. But does it ever do constructors ultimately return a value? If I create a new object, if I say player P equals new player, and then I try to print out P, what do I get? Memory address. Constructors always return a memory address. Therefore, modern languages don't require us to specify what it's going to return because that's what it's going to return is a memory address. Python, well, Python doesn't have return types, so we wouldn't have the opportunity to put that in there. But every single modern strongly typed language does not require you to put a return type on your constructors because constructors always boil down to memory addresses. So it does it for us automatically. If we roll back to an older language like Objective-C, we would return like a void pointer. So it's a memory address, but it's we would specify that we're returning that memory address. Very similar to what we did last week where we were showing some things that are invisible that we could put it there. It didn't break it, but we proved to ourselves that, oh, this stuff is there even though we're not seeing it. Modern compiled languages do a lot of quality of life stuff for us. All right, so let's take this getter out of here because we don't need that for right now. Let's just keep it as streamlined as possible. And also understand that when I say, like she brought up getter, that isn't anything specific. It more is just a meaning. If you want to give someone access externally to your class, to a private member in the class, one of your fields that you made private, you might want to provide a function that we would refer to as a getter function, which is just a function that returns that value. You can name it whatever you want. You don't have to put the word get in there. That's just the function that it produces for us. Some other languages like Swift have built-in getters and setters where you can put like a property value and how you want to have access. And what it will do is it will gatekeep, I like that word, it'll gatekeep your fields for you just by you saying, I want this field to be read only, I want this field to be read write, I want this field to be nothing, internal use only. So it lets you do that. All of those are solving the same problem. Am I going to protect my variables, or do I just rely on the user not misusing the tool? Either one's a reasonable enough approach. All right. But in this case, Java absolutely requires us to always say what kind of value a function is going to return or void if it's not going to return one. All right, so display is not returning a value. It's just going to display itself. And what am I doing for a room? I'm going to display the string room followed by a space, and then I'll put in the name of this room. All right, so this is all a room is going to start off as. It has a name. It has the ability to be constructed with different names, and then it has the ability for us to display it. So we can go back to driver here and test this. So let's get our dice out of here. So we're going to say room R1 is equal to a new room. Call that guy R1. We'll create another room, room R2. All right, if I run this program right now, what will my output be? Nothing. All programs begin and end with main. What does main say for us to do here? It says create two variables and do nothing else. What if I print out R1 and I print out R2? What would the output of this program be? Couple different memory addresses. Will they be the same memory address? Nope, different memory addresses. All right, so those are two memory addresses. This is what the default two-string method does for all objects in Java. And we also saw that this is what the default underscore underscore str underscore underscore method does in Python. By default, it gives you the memory addressy looking thingy. All right. Now, what if I say R1 dot display? What will the output of this program be?
Probably.
Here's room. Does room have a function called display? Does it take any parameters? Does it return anything? So I would call this guy using, and we're going to be talking about something called instance versus class methods relatively soon, but let's not worry about that right now. So we're just going to assume that all methods for right now are called using an instance of that class. So here in driver, I have R1. I'm saying R1, I want you to call your version of the display method. And R1's display method knows about R1's fields, including that his name is R1. If I were to ask R2 to call his version of the display method, that version of display does the same thing as R1's, but he knows that that particular instance of room is called, has a name called R2. So if I run this, we see here's our memory addressy things from when we printed out our objects, which is something we really wouldn't do other than teaching about it and trying to understand what's happening under the hood. Very rarely would you ever need to print out the memory addresses in your code. Similarly, very rarely would you, as I have found in industry, very rarely would you ever actually override the two-string method, because it's not that common for you to want to print out objects outside of things like strings. So if you happen to be making an object that you think kind of fits into the same category as something like a string, maybe you would override the two-string method so that you can directly print that object. Or you could just tell the object to print itself and move on with life. All right, so now we're going to create our two rooms, and then we're going to ask each of those rooms to go ahead and display themselves so we can see what's inside that room. All right. So programs begin and end with main. What does main say to do? Create a room, create another room, ask the first room to display itself, ask a second room to display itself. Questions about that? Go ahead.
This is like, it's the reason why I've gotten there the first time, but like, why if I decided to do system.out.println for R1.display? Like, I know there's like a really good logical.
Oh, but I'm going to make you answer it because you have all the knowledge you need to answer it. We just need to help you connect the dots. So she wants to do this. She wants to print out R1.display. And she currently gets an error. It says void type not allowed. So I'm trying to print out something that boils down to void. So if display returns nothing, what would you expect to display to the screen if you said system.out.println nothingness. That's kind of like standing in front of a soda machine and pushing buttons, but you never put the quarter in. So you're not going to get a soda from that thing, or pop, or what do we call it here? Soda? Soda. So I mean, you've got to make sure you connect all the dots of what's going on. So first of all, you tried to do this and it gave you an error. Not a big deal. Step 2, go read the error. The error is complaining about void, right? Funny enough, that's the step that most students skip. They assume, oh, I see red stuff, something's wrong. Let's just go randomly change crap. After you've messed with every single permutation of your 5 lines of code, in the end, you have something that works and you have no idea why. Okay. Read the error message, know what's going on. It is complaining about something called void. All right. Did I write void somewhere related to the display function? Yep. I said, when I wrote display, I said it will not return anything. Therefore, it will never make sense to print out what it was returning because it's not returning stuff. The error is warranted. It should be screaming at us, right? We don't want to get away with doing something that doesn't make any sense in the way we wrote this. Now, if we had changed this to return a string, and then just arbitrarily, we just decided that this function prints out what it prints out and then just returns LOL when all is said and done, for no good reason other than this example. But now we've said this guy returns a string, and we have returned a string. Now, do we expect this line to work? I haven't changed that line at all. It works now because system.out.println is going to print out whatever that guy boils down to. And he boils down to the returned value from calling R1's display method. And now R1's display method returns a string, specifically the string LOL. All right, so your error was not this line of code. The error was trying to do something that doesn't make sense to do. Or it pointed to, oh, I really should have been returning something, so why did I put void there? One way or another, it's pointing you to fix something in your program so that your expectations and what you wrote aligned. These are return types, not methods. So I know I'm harping on it, but it's super, you use a lot of random words that mean coding stuff. So I'm not saying that to make fun, but you want to make sure you know exactly what you're talking about with those words. So this guy right here is a return type. When we talk about functions, we have return type, we have function name, we have our params. And then in here is our logic for that function. So when we're talking about this first thing here, we're talking about what kinds of things will this function ultimately spit out. All right, so every time we want to talk about that, it's our return type. This is our function name. This entire thing here would be a function. So, so now ask your question.
Is void display considered a method if it's not returning?
Oh yeah, this is a method that returns nothing. It still does stuff. I mean,
because you said the constructor, because I mean I thought it was a method since we had public, but you said it wasn't because we weren't returning.
Public is unrelated to whether it's a method or not. Public, no, public has nothing to do with returning either. Public has to do with where you have access to it. But I'm purposely leaving that off here so it just behaves like Python behaves, where you have access to your fields externally if you wanted them. Okay, but when we're just talking about functions themselves, this guy right here is a constructor. Even though he looks a lot like a function, he doesn't have a return type because constructors never do. And his name matches the class name identically. Those are laws in Java. Your constructors have to match your class name. Your class name has to match your file name. All those things have to align. And constructors never actually have a return type because the return type will always be a memory address. And we can even finish the connecting the dots there by seeing how we're calling that constructor. every time we call upon that constructor, we're using the new keyword before it. And the new keyword is like our real estate agent in the operating system. Its job is to go out and find us some memory out in the computer that's big enough to hold a room. All right. So let's get rid of this guy here. All right. So in this case, display is not going to return anything because I'm going to say room, I want you to display yourself, and it's going to spit something out to the screen, not spit something back to the user who's writing the code. All right. So define my rooms. Ask each room to do something. Oh, yeah, whatever. All right. So now let's write player in our notes here. And we're going to expand on these things, but let's just start getting the skeletal structure of our program going here. We built a room in its most basic form. Now let's build a player in its most basic form. So we'll go through a very similar thought process here. We'll say player.java is going to be the name of the file that contains our class called player. We're going to have a class called player, which must match the name of the file, case sensitive and all, capital P in this case. Then we're going to have our constructor. So this guy is going to be called player. We're going to say players are going to take in a name. We decided to design this guy so that all players have a name. So since I am in a strongly typed language, I have to go and define my fields at the top. I have to say, here's the fields that belong to this guy so we can fill them in the constructor. So I'll say string name. This dot name is equal to name. All right. So for right now, that's all a player is. And we can even let a player display himself as well, just so we can tell he's different. So we'll say void, we'll name the function display again, and we'll say system.out.println, and we'll spell out here player and follow it by his name. Yep. Well, it's a good question. So let's start off with here. I'm going to answer it. I'm going to answer it in 15 seconds. Let me just write the example in main. So let's just come out to main here and let's go ahead and create our player. All right, so there's our player. And then we're going to say P1 dot display. So we'll create our instance of player. We're going to ask that player to display itself. Displaying that player does not return a value, but it does spit some stuff out to the screen, print some stuff out to the screen. So we should see that this guy now shows our player. So there's our player Mike. All right, so now she was asking the question about the this dot thing. Okay, and this is important. Pun intended. All right, so what happens if I take the this dot off of there? If I run this program now, what am I going to get? It's actually a really good question because it lets me exemplify something here. Well, let's follow it. So don't just guess what you think it should do or what you hope it would do. What does it actually do? If I go out here to driver and I create my player here, and then I ask that player to call upon one of his functions, it's going to do whatever that function says it should do. If we just did system.out.println P1, we'd get the memory address because that's what objects hold. They hold memory addresses. But in this case, I'm asking that object to do something, namely call your display method. And that player's display method does this stuff. So what's the output of this program going to be right now? We saw that it printed out Mike when I had this dot name there. But if I take the this dot off, do you think it'll print the same thing, or did you test it now? You know it prints the same thing. Okay, so now tell me, well, here, we'll show it, and then you get to tell me why it prints the same thing. The reason it prints the same thing is super important in the giant realm of programming. It involves scoping. So tell me why it prints Mike, whether I say this dot or not. The important thing here is this dot is not necessarily optional. We have to know what we're doing. Go ahead. In the back. Yep. Whether it's public or not doesn't matter in this case since we're inside of the class.
Is it because we have the name to P1? So like P1 was automatically given that name, and we didn't necessarily need this in order to get that,
Why didn't we need this?
because it was already established in player. Once we put it into P1, it went into player, and then now we could just call it.
Okay, so let us throw us into the wall. Oh, go ahead. I'll give you a shot. It'll still work. So here, I'll take that off. We'll go out here. We'll create a new player. Player P2 is equal to player Dave. And then we'll say P2 dot display. So we'll see Mike and Dave. And if we go into our player class and we put the this dot back in there, we'll still see Mike and Dave.
You make the field, you're saying that the name instance for that, like for that class, equal to the name parameter. So it would make sense that you can still use, like if you reference date, you're referencing your instance of name.
Okay. I think the answer is actually simpler than all this. Let's go ahead. Say the beginning part again. I'm sorry.
It's not even set the names are the same thing.
Okay.
Yeah.
That's the answer. It's the wrong answer, but it's the answer I wanted to hear. So when we put this dot on there versus not putting it on there, and we see the identical result, we might think, oh, this dot's always optional. That always piece is the killer there. Does that mean that I can just say name equals name up here? The hack here would have been to call this guy like player name, and then we can say player underscore name equals name. This is all involved with the correct answer here. So I can either have my fields be unique to the names of the parameters passed into the constructor, which isn't really good programming practice because presumably the parameter we took in being called name that describes the value we're holding there. So it makes sense that the top level value would also be the same thing, which would require us to say this dot name. So this is kind of the starting point of the problem. If you decide to name your fields identically to the parameter coming into your constructor because they're both holding the same pieces of information, therefore, why shouldn't they be called the same thing? If you decide you're going to do that rather than make the shortcut or the hack to get the thing to stop yelling at you, and we put this in here, is what's going to happen right now if I run this program? Ran just fine, no error. Got a little bit of a weird result. This is the result of calling display, right? What does display do? It prints out the current name. This variable right here was never actually set. So its default value is null, or if we were talking Python, it would be none. When I say name equals name, I'm going to put this in the notes. It's probably in here somewhere already, but I'm going to, important thing. Variable resolution. All variables resolve to their most local definition. And that's what's really going on here. Scoping rules. When I say name here, and I say name here, each of those resolves to their most local definition. And the most local definition of name is the one that came into the constructor here. So when I say name equals name, I'm saying I want this version of name, the one that is the most local version of name. I'm going to set it equal to itself, just wasting my time. I've never set this guy up here because this version of name shadowed this. I have a more local version of name than this global one. But if I say this dot name here, now I'm bypassing that. I'm saying don't resolve to the most local definition. Instead, I want you to set this particular instance of players name variable equal to whatever is the most local definition of name, which is this guy right here.
So is this?
Well, let me just do the final follow through. Okay, so that's what is happening in the constructor. So in the constructor, this dot name is not actually optional if I have an intention of setting my fields. I have to reference my fields, and I need to do that by the scoping rule. So I either have to have unique variable names, so it finds the local one, it doesn't confuse them, or I leverage the this keyword to say, I want to set this guy's name equal to the name that was passed in. But now when we get down to display here, again, all variables resolve to their most local definition. When I say name right there, is there a more local definition of name there inside that function? I haven't defined one. So I don't actually have a local version of name. So it checks locally, and then it says, okay, well, I'm going to go ahead and check the next level up. And the next level up is that guy. So it found the name field after it first looked here, didn't find it, and then jumped up to the more global scope where name exists. That is why we didn't actually have to say this dot here. Technically, this dot would be a little bit quicker, not noticeably quicker by a human being. Probably not even noticeably quicker if you were running this against like a, some sort of stress test or something. But in this case, it doesn't even try to look locally. When I say this dot name, it's not going to see if I have a variable here called int name is equal to 4. Even though that doesn't make any sense, it's not going to check for that. It's just going to go right to that top level thing. So if I go and run that, we see we still get Mike and Dave. But if I take this dot off of here, and there is a more local version of name, and this version of name holds it, it's a completely different kind of variable. This guy holds an int instead of a string, and I just randomly put the number 4 in there, but now it'll print out 4 for the both players because a variable resolves to its most local definition, and now there is a more local. Why was that alarm set? Well, whatever. I bet you I didn't set my 11:20 alarm, so somebody will have to yell at me when I start going over. So even though this variable named name is a different type and holds a different completely type of value, it is the most local definition of name here. Therefore, it's printing out that guy. Go ahead.
Can you just again review the difference between this dot name and like what is the difference between like me and this?
Yeah.
Me.
This guy up here, the field. So these are our fields. Now, as a starting point, it is normal to find this confusing, but it is fundamental to all programming, not Java programming. So it's good that you're asking questions, because usually I'll say something like, any questions? And then, you know, somebody's still snoring and all this stuff you're not paying attention. So these are good questions. I don't want you to feel like, oh, why am I just not getting this? All right. So when we have our collection of fields that traditionally we put at the very top, technically they can be put anywhere within this opening curly brace and this closing curly brace, as long as they're not inside any of our constructors or methods, but we typically just put them at the top. So we have all of our fields. These are variables owned by this object. Whenever I want to talk about these guys directly or without any ambiguity, I will call it this dot, whatever the name of the field is. This guy's name, if I'm the instance of a player. Inside of this constructor here, I'm setting my name, guy up top, equal to whatever this guy resolves to. And name resolves to its most local definition. And we actually find a more local version of name here than this guy. So I'm setting this guy, this dot name, equal to this guy, the name that was passed in. Okay, that's that distinction. Now, if you follow scoping rules and you've been coding for a while and all this stuff is crystal clear, you can choose whether to write this dot or omit writing this dot in situations where you just know it's going to work. I would call that bad programming practice, though. There's two benefits to always specifying. If I mean one of the fields up here, if I mean that guy, one benefit of saying this dot name is it's potentially gaining a little bit of speed, because I'm saying don't even look locally, just it's up there. But also, if I type in this dot, it gives me the correct spelling. In this, it does, if you use like Eclipse or one of these other IDEs for writing code that's not just sitting in a web page, as soon as I hit the dot, when I say this dot, it would give me a list of all the things owned by this class, all the instance members of this class, all the fields, all the other methods. So I can go and pick the guy in there and not misspell it. I have bad tremors in my left arm. I can't see my keyboard very well because I wear VR contacts, not the glasses I need. I make spelling errors. So that's beneficial. Double whammy. Go ahead. And then I'll come to you.
Memory address, like if you were to print the memory address of this dot name, it would not equal the memory address of name.
This is the memory address of name. If I were to say system.out.println, that will be the memory address. The memory address of this player. We don't have the memory address of name. Name holds a string.
Gotcha.
Yeah. So this inside here is the same thing. So let's go, we'll print it here. And I know we've done this before, but let's just keep driving the point home. So when I'm building my players, it's going to print out those memory addresses. So what I'll do is after each of these, I'll also print out the value of the variable we just set. So this will print out a memory address. This will print out a memory address. Inside the constructor, I'm printing out the value of this keyword. Remember, this is how an object refers to itself from within itself. So inside of this instance of player, if I want to talk about myself, it's called this. From outside of that guy, if I want to talk about myself, I refer to it by the variable it holds. So I'm either P1. So for this particular guy, this is equal to P1. And for this particular guy, this is equal to P2. But this is how we refer to them outside of the class by their variable names. Inside of the class, it's always this dot, this particular player. So we should see memory address printed. So this is going to first print the value of this inside. Then it's going to be printing the value of P1 outside. Those should be the identical memory addresses because they're both pointing to the same place. We just have two different variables that point to that. And then similarly, this will print out this during the creation of P2, which is identical to the address that P2 will ultimately hold. So we're going to see two. Whoa. Have my this dot somewhere? I was in the middle of doing something clearly. Actually, we'll just leave that in there too. We'll get a memory address out of it. So this is the first this is P1. This is the second this in the constructor. This is P2. Same memory addresses. They're literally the same variable. We just don't have access. If I go inside player here and I try to print out P1, which we know exists, it just exists somewhere else. Variables resolve to their most local definition. I have a variable called P1 here. It's going to look locally first. Is there any variable defined in there called P1? Nope. Not going to find it there. It's going to jump up to the next level and say, well, is there a variable up here called P1? Nope. Well, I've hit the top of the line here. I've checked everywhere available to me. I've checked everywhere in my scope, everywhere I can see from inside this constructor, and I do not see P1. Therefore, I'm going to scream about it. So we're going to get that red error. Can't find it. Even though it definitely exists. It just exists in an entirely different scope. A place that we don't have access to inside a player. Make some sense? All right, go ahead.
So the constructor string name is being initialized to the local variable. This not name.
Where are we looking? Okay.
This is the constructor string name, like right there, being initialized to the local variable. This dot name, or is
So, well, hold on. Let's just talk about this line. So you're asking about this guy right here?
Yeah.
He is being set to the value that we pass in to that constructor. So the first time that variable is equal to Mike, the second time that variable is equal to Dave. So inside of because this is me calling that constructor after the new keyword. So if I'm inside of this constructor here, this variable holds the string that was passed in when this constructor was called. First time it's Mike, second time it's Dave. All right, go ahead.
being initialized to the global variable, this dot name? Or is it?
So in here, this dot name refers to this guy.
And that's cool.
It's global inside the player class. Yeah, but I mean, it is global, so that is an accurate way of calling it. It's global inside the player class, but probably the most correct way of referring to it is this is the name field of this player. So when we say this dot, we're talking about fields, or we're talking about other methods that we own. But in this case, we're talking about fields. Okay, so I'm saying I want to set my field called name equal to the variable name that was passed in. Now, I'll go ahead and run this again. Notice here when I have my player, this is my display. And I'm not even using this more local variable here. We'll go back to that here in a second. But why am I getting a memory address right here? What's actually printing here? Hmm? Well, that's what the result is a memory address looking thing. But what's actually being called here when I concatenate on to this, the value of this? That guy right there. So the stuff we talked about last class, we're inside of the inner workings of these languages and seeing how they're all built the same. We did the string, toString, and we did the underscore str thing last time. That's what's happening. The good news for us is we very rarely are going to work with memory addresses in modern programming languages. We just want to know they exist. And we want to know that if this guy's a memory address, holds a memory address, and I change the value of this guy, I potentially just lost my thing in memory. So if I go to driver and I say P1 is equal to P2, and then I say P1 dot display and P2 dot display, I'll check it here in a second. Let me just get us back to the thing that prints out the Mike and Dave. All right, so I define my Mike. And we'll go ahead and take out these extra memory addressy thingies. Just to streamline this a little bit. Okay, I took it out of there already. Let me run this one more time. All right, so I created Mike. I created Dave. If I were to print out P1.display right here, it's going to print out Mike. Then it's going to print out Dave. There's Mike, there's Dave. So P1.display printed out Mike here, but P1.display printed out Dave here. Why? This line right here, I am overwriting the value stored inside of the variable named P1, which used to hold a memory address which pointed to one player. I'm overwriting that with the memory address that's stored in P2. So now P1 no longer points there. P2 now points to the same place that P2 points to. Meaning that this place in memory up here where P1 isn't retrievable anymore. Nobody else points to that. Does that make sense? So automatic garbage collection is going to come through and clean that up because this line right here says disconnect P1 from its original value and point at the same place as P2. That's what that line right there says. So we are abandoning P1 that used to be in memory up here, and now we're pointing to the same place as P2. P1 points there, P2 points there. And this guy's voted off the island. All right. So this is all pointer stuff as programmers, modern programmers. This is the stuff that we need to make sure we keep track of in terms of pointers still exist. We just won't be working directly with memory addresses very commonly. Go ahead.
Now from here, what if you don't want the player to print out?
If I want to print out the memory address, I would just take the name off of it and just say print out this instance of player where it'll call his toString, and now it'll be that memory addressy thing again. You very likely would never do that, you know, in practice, because the memory address is where it lives, where the operating system put it for us, really isn't all that important to us. We don't care where it put it as long as it put it somewhere that we can access. This is more just proving that it is putting it in some place in memory so we can kind of see it's a distinct place in memory from this other thing that was in memory. let me take out the, well, I'll just comment out that line. So now I don't overwrite P1, and we see that P1 and P2 are in distinct places in memory. Those are two different memory addresses. All right. So back to this guy right here. Let me make sure that I'm not printing a bunch of extra crap in here. So we'll see P1, P2 dot display. So create our two players, ask each of them to display itself. Don't do any overwriting stuff anymore. So we should see we get a Mike and we get a Dave. So now we're back to this question of, well, if I don't put this dot here, it still prints Mike and Dave. And now we understand why that this dot wasn't absolutely required here, because variables resolve to their most local definition, and the most local definition of name here happens to be the field name.
Which is our set.
It was set somewhere else, but that part doesn't even matter. Some other part of our program presumably set it, but we're just talking this one line right here. If I want this player's name to display, I don't technically need to say this dot in this case, because the most local definition is the same thing as this dot. But if for whatever reason there's a more local variable called name, even if it's a completely different type, now name resolves to the most local definition, which is that local one. So now we get fours instead of Mike and Dave. Make sense what's going on there? My argument would be, whenever you are talking about your fields, always put this dot in front of it. A little bit quicker, fewer spelling errors, and you'll never screw up, meaning you'll never accidentally resolve a local variable when you knew right from the get-go that you meant the guy at the top. So don't try to figure out whether you need it or not. It's not hurting anybody. In fact, there are benefits. So always put this not name there. And if I do that, then it doesn't matter that there was a more local definition here, because I am explicitly saying I want to talk about my field called name. So we still have the Mike and Dave. All right, make some sense? All right. And then secondarily, and I'm glad he pointed it out, but this is the thing we just talked about, and this is going to be sad, but the thing we just talked about probably is only understood by less than 50% of professional software engineers, even though it seems very simple. It's because when they learned it, they probably learned to just name their field something different than what was passed into their constructors, because it works, but they never learn why it works. Just, oh, don't name them the same thing or things will break. Make some sense? All right. So I would double down and say it is horrible programming practice to just purposely name your field something different. And you've probably seen this in books before, or seen this in active code, and they try to make it look fancy. They'll do something like that, where it's basically the same thing, but we just put that little underscore before it. And now it still will work. So now right here, I can put the underscore name. I think underscore is allowed in a variable name. I guess we're going to find out. Yeah. They definitely do this in scripting languages. I just don't know if I've ever tried it in Java. Underscore is an allowable thing for your variable names to start with. So this would be the hack for someone that's trying to make it look like it was on purpose, by just giving it a different name with a little underscore. I'd call that bad programming practice. You're not getting fired over it, because chances are your team supervisor didn't know that either, or didn't learn this until after he'd been in industry for 5 years. Then at some point he was debugging some other program and like, what the heck is going on here, and stumbled upon it. All right. So your constructors pretty much should always say this dot field name is equal to whatever value was passed in. Always have the this dot there. All right. So out in driver, we have our 2 rooms, asking each room to prove that they exist by displaying themselves. We have our, I'm just going to drop down to 1 player, and we'll have that 1 player display itself. So now we need to put a player into the room, because ultimately rooms will have players in them. So in order to do that, in our last minute here, we'll go to room. We're going to add a field. Rooms don't just have a name now. They also know about a player that is potentially in there. So we're going to say player. I'm going to call it the player. But when a room is first born, it doesn't come with a player pre-installed. So we'll just go ahead, and you wouldn't have to do this because the default value is null, but good programming practice would say, explicitly say, this room is born with its name field set to whatever name the room has, and its player field purposely set to null. So we visually see this room does not currently have a player in it. All right, we'll come back next time. We'll go ahead and put the player in there, and then we'll also write the code to make sure the room lets the player know what room it's in. And that's going to be another good use of the keyword this. Questions, comments, concerns, bribes?
The player as an extra point.
Because when a room is born, it doesn't have players in it. If I have 2 rooms, I'm not going to put Mike in both rooms. Can't be in 2 places at once. So presumably we're going to build the room first. It's going to be sitting there, and then we can choose to add a player to the room later. Not when, not when it's constructed. It's sitting there empty, and we'll just throw them in there when we're ready to put him in there. Yeah. Ultimately, he's still in there. It's just when he walked into the room. Yep. What's up?
Office hours.
Well, I set up appointments, but I can meet with you now if you're available now.
Actually, I
Okay.
grab a lunch, but I can shoot you an email.
Sure. And we can just set something up
Yeah,
and
wonderful.
either here on campus or we could jump on Zoom, whatever you want.
Sounds good. Yeah, whatever's convenient.
Yep.
Appreciate it.
I got plenty of times, just I don't want to sit in my office for 3 hours and have nobody show up. So